Hey everyone, welcome back to the channel. In this video, we're going to take a structured end-to-end walkthrough of Azure Databricks Lakehouse architecture, not just at a surface level, but in a way that actually helps you understand why things are designed the way they are. If you've seen Lakehouse diagrams before and felt like they explain what exists, but not why it exists, this video is for you. Here's exactly what we're going to cover. We'll start with a high-level overview of the architecture. This is where we zoom out and understand the big picture, what a lakehouse is trying to solve, and how Azure Databricks fits into a modern data platform. Then we'll move into the high-level architecture itself, how data flows across layers, what sits where, and how different workloads coexist on the same platform. After that, we'll answer a very important foundational question. What are ACID guarantees on Databricks? Why they matter, and how Delta Lake brings reliability and consistency to data lakes, which traditionally lacked both. Next, we'll talk about the Medallion Lakehouse architecture, bronze, silver, gold. We'll break down what each layer represents, why this pattern is so widely adopted, and how it helps teams scale pipelines without chaos. Then we'll discuss something that every organization talks about but struggles to achieve, building a single source of truth. What does that really mean in practice? How the Lakehouse enables it, and how governance and shared data foundations make it possible. From there, we'll look into data discovery and collaboration in the Lakehouse, how users find data, how teams collaborate safely, and how governance doesn't slow things down, but actually enables trust. Once that foundation is clear, we'll move deeper into Lakehouse architecture design. We'll talk about what makes a well-architected data lakehouse, not just from a technology standpoint, but from scalability, reliability, and operational best practices. Then we'll define the scope of the lakehouse, what belongs inside it, what doesn't, and how to avoid turning it into another monolithic system. After that, we'll go through the guiding principles behind lakehouse architecture, design principles that influence decisions around ingestion, storage, processing, governance, and consumption. And finally, we'll bring everything together with the reference architecture. This is where all the concepts connect. Sources, ingestion, storage, transformation, serving, analytics, and governance. So instead of memorizing components, you'll understand how the architecture actually works as a system. By the end of this video, you should be able to look at any Azure Databricks Lakehouse architecture and confidently explain what each part does, why it exists, and how it supports analytics, BI, machine learning, and AI on one unified platform. All right, let's get started. Talking about Azure Databricks, the high-level architecture. At the very top of the chain, we have something called an Azure Databricks account. Think of it like the control hub for everything Databricks in your organization. This is where you manage users, groups, service principals, basically all the identity and access stuff. You also manage workspaces here, create them, delete them, move them around different regions, that sort of thing. And then there's something called the Unity Catalog Metastore. Now, don't let that fancy name scare you. The Metastore is basically the central system where all your data assets live. Tables, machine learning models, you name it. It's structured in a neat three-level namespace: catalog, schema, and object. And the best part? You can attach a single metastore to multiple workspaces, so every workspace sees the same data in a consistent way. Okay, so that's the account level, pretty high up there. Now let's zoom in a bit and talk about workspaces, because this is where the real action happens. A workspace is essentially your collaboration environment. This is where users run jobs, explore data interactively, train ML models, or even schedule jobs. Think of it as your sandbox for all things data. Now, here's a critical piece to understand. The architecture is split into two main planes, the control plane and the compute plane. Let's start with the control plane. This is managed entirely by Databricks, so you don't have to worry about it. It's the brain behind the operations, the web app, the management services, all that stuff. It's kind of like the command center. Then we have the compute plane, where the actual data processing happens. And here's where things get a little interesting, because Databricks offers two flavors, classic compute and serverless compute. Classic compute runs inside your own Azure subscription. That means all the clusters and resources are in your virtual network. It's naturally isolated because it lives in your subscription. This is great if you want full control over your networking and security. Serverless compute, on the other hand, runs entirely within Databricks' managed environment. It's still in your region, but Databricks handles all the provisioning and scaling for you. And don't worry, it's secure. And each workspace has its own network boundaries and isolation layers to protect your data. Now let's talk about workspace storage, because serverless and classic handle it a bit differently. Serverless workspaces use default storage, which is fully managed by Databricks. You can also connect it to your cloud storage if you want. Classic workspaces, however, use a dedicated storage account in your Azure subscription. This storage holds system data, Unity Catalog workspace catalogs, and in some cases the legacy DBFS. But heads up, DBFS is kind of being phased out, so Databricks recommends using newer patterns. So if we take a step back, here's how it all ties together. You have the account at the top managing everything, a control plane that coordinates the operations, and a compute plane that actually does the work, either in serverless or classic mode. And then there's the storage, which keeps your data safe and organized depending on which workspace type you're using. And honestly, when you look at it this way, it starts to make a lot more sense. You're not just throwing data into a black box. There's a clear hierarchy, clear responsibilities, and a path for scaling as your data and workloads grow. Azure Databricks architecture might seem complex at first glance, but if you break it down into account, workspace, control plane, compute plane, and storage, it's actually a very logical system. It's built to give you flexibility, security, and scalability all in one. Before we start discussing about Medallion Lakehouse architecture, it is important to understand the concept of ACID transactions on Azure Databricks, and more specifically, how Delta Lake makes sure your data is safe, consistent, and, well, trustworthy. Okay, first things first, ACID, it's an acronym. Atomicity, consistency, elation, and durability. Big words, right? But basically, they're just fancy ways of saying, hey, your data is going to behave the way you expect it to. Let's break it down. Atomicity. It just means that a transaction, like say updating a table or adding some records, either happens completely or not at all. There's no in between. Imagine you're adding 10 rows to a table. Atomicity ensures either all 10 get added or none of them do. No half-done stuff that could mess up your reports. That's a relief, right? Next up, consistency. Think of it as the rules of the road for your data. Whatever you do to your data, it always moves from one valid state to another. Delta Lake checks your transaction, validates it, and only then commits it. So your data isn't just random chaos. It's always, well, consistent. Now, isolation. This is where it gets interesting. Let's say two people are writing to the same table at the same time. Could be chaos, right? Delta Lake uses what's called write serializable isolation. Long story short, it means your writes don't step on each other's toes. And for reads, it uses snapshot isolation. So you're always seeing a consistent view of your data, even if someone else is making changes in the background. Pretty neat. And finally, durability. This is the don't worry, your data is safe guarantee. Once a transaction commits, it's permanent. Delta Lake stores everything in cloud object storage, which is super reliable. So even if your cluster crashes or your laptop explodes, well, maybe not the laptop, but you get the idea. Your data is safe. All right, so that's the ACID part, but how does it actually work in Azure Databricks? Let's look into this. Every table backed by Delta Lake has a transaction log. When you write data, Delta Lake stages it, validates it, checks for conflicts, and then commits it as a new version. That's why it's atomic and consistent. And the cool part? You can have multiple clusters or even multiple workspaces writing to the same table at the same time without corrupting the data. Delta Lake handles the conflicts, so your table stays clean. Now, one thing to keep in mind, Delta Lake transactions are table level only. So if you're updating multiple tables in one go, each table gets its own transaction. No multi-table transactions yet. But honestly, for most use cases, table level is enough. So to sum it all up, ACID transactions in Azure Databricks with Delta Lake make your data safe, reliable, and consistent. Atomicity makes sure your writes are all or nothing. Consistency keeps your data rules intact. Isolation prevents chaos when multiple processes are working at once. And durability, well, your data survives crashes, outages, you name it. It is also important to understand and talk about the Databricks Lakehouse and how it helps organizations manage data in a smart, unified way. Yeah, that means no more messy copies of the same data floating around everywhere. So let's start with a question. What does it even mean to have a single source of truth? Sounds fancy, right? But it's actually pretty simple. Imagine you're running a business and different teams are using the same data set, but each team has its own copy. Now imagine that one copy gets updated and the others don't. Chaos, right? That's what we call a data silo. Teams end up working with information that's inconsistent, outdated, or just wrong. A single source of truth, or SOT, fixes that. In the Lakehouse, your data lives in one place, and everyone, yes, every analyst, engineer, and AI model can access the exact same data. No more guessing, no more conflicting reports. Now, you might be wondering, how does the Lakehouse actually make sure that all this data stays safe and accurate? Well, that's where Delta Lake comes in. Delta Lake uses something called ACID transactions: atomicity, consistency, isolation, and durability. Basically, it's a fancy way of saying that when data gets updated, it happens all the way every time and everyone sees the right version. And thanks to log files stored right alongside your data, Delta Lake can handle multiple people reading and writing at the same time without crashing into each other. That's huge for businesses running real-time analytics. Okay, so your data is safe and everyone's looking at the same truth. But what about who can see or change what? That's where Unity Catalog comes in. Think of it as a super smart gatekeeper. You can give read-only access to some users, editing permissions to others, and even control access to specific cloud storage locations. Everything is tracked, auditable, and centralized, so you don't have to worry about random people messing with your production data. And here's another cool feature: views. Views are basically saved queries that give you a live window into your data every time you run them. Unlike static tables, which are fixed once they're written, views always show up-to-date results. So if you're an analyst or a data scientist, you can pull fresh data without having to worry about rerunning massive jobs all the time. Plus, you can share these views safely using Unity Catalog, which means your team can stay aligned on business logic and calculations. Speaking of sharing, let's talk about collaboration beyond your own team. Delta sharing allows secure read-only access to data sets for people outside your organization, or even across different departments. That could be giving regional analytics access to international teams, sharing customer-curated datasets with partners, or just making sure everyone sees the same numbers. It's real-time, secure, and doesn't involve duplicating data all over the place. Finally, let's touch on discovery and speeding things up. Databricks has something called Catalog Explorer, which lets you browse all available datasets, see their history, and track where they came from and how they're used. And because the Lakehouse supports SQL, Python, Scala, and R, your team, regardless of their skill set, can all work together on the same data. Analysts, engineers, and data scientists all using the same datasets without headaches. Not only does this make work faster, but it also keeps your insights consistent and trustworthy. So to wrap this up, the Lakehouse is basically your one-stop shop for data. It keeps your data safe, consistent, and up-to-date. Unity Catalog and Delta Sharing make sure the right people can access the right data and views, plus multi-language support make analytics flexible and fast. If you're building dashboards, AI models, or reports, everything comes from the same trusted source, and everyone stays on the same page. And that's why the Databricks Lakehouse is such a game changer. It's not just about storing data. It's about making your data work for you, safely, securely, and efficiently. Let's talk about the Medallion Lakehouse architecture. At a high level, the Medallion architecture is all about layers. Think of it as a journey your data goes on. It starts messy, then it gets cleaned, then it becomes useful. Those layers are called bronze, silver, and gold. And no, that's not just marketing. Each layer actually represents the quality of the data. So let's start at the beginning, the bronze layer. Bronze is raw data, and I mean raw. Files landing in cloud storage, events coming from Kafka, data pulled from Salesforce, logs, IoT data, anything and everything. In the bronze layer, we don't judge the data. We don't clean it. We don't fix it. We just store it. Why? Because bronze is your single source of truth. If something breaks later, if business logic changes, if someone asks, what did the data look like 3 months ago? You can always go back. This is also why bronze data is usually appended only. It grows over time, it keeps history, it's perfect for auditing and reprocessing. Now, here's something important. Azure Databricks actually recommends doing minimal validation in bronze. You'll often store fields as strings or variants. Why? Because schemas change, columns appear, columns disappear, and you don't want ingestion to fail just because the source changed overnight. Bronze is about safety and completeness, not perfection. All right, once data is safely stored in bronze, we move up to the silver layer. This is where the real work begins. Silver is all about cleaning and validation. This is where data engineers roll up their sleeves. Null handling, deduplication, schema enforcement, typecasting, out-of-order records, late arriving data, all of that happens here. You might also start joining data sets, customers with transactions, accounts with opportunities, raw leads turned into cleaned leads. And here's the key thing. Silver data is still detailed. It's not overly aggregated, it's structured, reliable, and ready for serious analysis. This is why silver is loved by data analysts and data scientists. They can trust it, but they still have enough detail to explore patterns and build models. Now, quick correction. People sometimes try to write directly to silver from ingestion. Don't do that. Databricks strongly recommends ingesting into bronze first. Why? Because ingestion pipelines break. Sources send bad data. Schemas change. Bronze protects you, silver builds on top of it. Okay, now let's talk about the top layer, the shiny one, the gold layer. Gold is built for the business, executives, business analysts, BI tools, dashboards, reports, applications. Gold data is highly refined, highly aggregated, and aligned to business logic. This is where you'll see things like customer spending summaries, daily account performance, sales pipeline metrics, executive dashboards. Gold answers questions, simple questions. Fast. How much did we sell this week? How is the business performing? Which region is underperforming? And the gold layer is optimized for performance because these tables get queried a lot. This is also where dimensional modeling usually lives. Facts, dimensions, measures, relationships, and sometimes you'll create materialized views like weekly sales or monthly revenue. So analysts don't have to recompute the same logic over and over again. Gold is about clarity and speed. Now, one more thing that often gets overlooked: cost. The Medallion architecture helps control cost too. You don't need to ingest everything continuously. Some data can be streaming, some data can be triggered, some data can be batch. Bronze might ingest frequently, silver might process incrementally, gold might refresh on a schedule. You choose the balance between cost and latency. The Medallion Lakehouse architecture is not magic, and it's not mandatory, but it is a proven pattern. Bronze keeps your raw truth. Silver gives you clean, reliable data. Gold delivers business value. It creates structure, it creates trust, and it scales as your data grows. If you've ever struggled with data chaos, this architecture gives you a clear path forward. So far, we touched upon the Azure Databricks architecture, ACID transactions, Medallion architecture, and all of the features of Databricks Lakehouse. But we also need to understand the complete scope of Lakehouse platform. The Databricks Data Intelligence Platform covers the complete modern data platform framework. It is built on the Lakehouse architecture and powered by a data intelligence engine that understands the unique qualities of your data. It is an open and unified foundation for ETL, ML, AI, and DWHBI workloads, and has Unity Catalog as the central data and AI governance solution. Now, if you've ever wondered how companies manage massive amounts of data, build AI models, and run analytics all in one place, this is the topic for you. All right, let's start with the basics. What exactly is a lakehouse? Well, think of it as the best of both worlds. It combines the flexibility of a data lake with the structure and reliability of a data warehouse. And Databricks has taken this idea and built it into a complete platform they call the Data Intelligence Platform. It's kind of like having a Swiss Army knife for data, everything you need all in one place. Now, the platform isn't just for data engineers. It's designed for all the key players who work with data. You've got your data engineers who basically make sure that the data is clean, reliable, and ready to use. They're the ones building all those pipelines and ETL jobs, so data scientists and analysts can actually do their thing without worrying about missing or messy data. Then there are data scientists who take that data and turn it into insights. They build predictive models, spot trends, and basically translate raw data into stories that business leaders can understand. And of course, ML engineers, they take those models and make sure they actually work in the real world at scale without breaking. And we can't forget business analysts, business users, and even app developers. They're all part of this ecosystem, using dashboards, apps, or direct queries to get the insights they need. Oh, and data sharing is huge too. Business partners, vendors, or other third parties can securely access data without a headache. That's the magic of a well-governed platform. Let's talk domains, because the platform isn't just a bunch of tools thrown together. It's structured. At the base, you've got your storage, cloud-based, scalable, and resilient. On top of that, there's governance with Unity Catalog, which handles things like access control, auditing, and metadata management. Basically, it makes sure your data is secure, organized, and trustworthy. Then there's the AI engine, and this is where it gets exciting. Databricks AI isn't just some add-on, it's built into the platform. You've got everything from machine learning and deep learning to generative AI and large language models. Spark structured streaming and declarative pipelines handle real-time analytics, while Mosaic AI makes model deployment and serving straightforward. Don't forget the data warehouse and operational database pieces. Databricks SQL lets analysts query the data warehouse with full governance, and Lakebase integrates transactional workloads so your OLTP and OLAP data can work together seamlessly. And of course, orchestration, ETL, notebooks, MLflow for experiments, BI tools, apps, dashboards, even secure collaboration through Delta sharing and clean rooms. It's all there. Seriously, the platform covers the full lifecycle, from raw data ingestion to actionable insights in a way that's scalable, governed, and collaborative. So to sum it up, the Databricks Lakehouse platform is basically your all-in-one solution for modern data and AI. It makes it easy for teams to work together, keep data secure, run analytics, deploy ML models, and even collaborate with external partners. And the best part? It's all built on open standards, so you're not locked into proprietary format. So after understanding the Lakehouse Business Intelligence Platform scope, let's deep dive into the guiding principles of Lakehouse that make it work. So what is a lakehouse? Well, think of it as the sweet spot between a data lake and a data warehouse. It's where all your business data lives in one place, structured in a way that makes it super easy for analytics, AI, and reporting. But having a lakehouse isn't just about dumping data in one spot. That's where guiding principles come in. These are like the rules of the road. They tell you how to build, maintain, and trust your lakehouse so it actually delivers value. Let's start with one of the biggest ones. Curate data and offer trusted data as products. Sounds fancy, right? But it's really about thinking of your data like a product. That means you define it clearly, you know its schema, and you manage its lifecycle carefully. One really smart approach here is to structure your data in layers. You've got your ingest layer first. This is where all raw data enters the lakehouse. Think of it like the loading dock at a warehouse. Everything gets dropped off here. Then comes the curated layer, which is where the magic happens. Data gets cleaned, refined, filtered, maybe even aggregated. This is the layer where you make sure the data is actually trustworthy. And finally, you have the final layer, which is basically your business-ready data. This is where you prepare the data for reporting, analytics, AI, all the end-user stuff. And here's the key. As data moves through these layers, its quality improves. That's what makes people actually trust it. Next up, something that might seem obvious but is often overlooked. Eliminate data silos and minimize data movement. Basically, don't make copies of data and let business units rely on them. Copies might sound harmless at first, but if they start becoming operational, you're looking at silos that are out of sync, messy, and confusing. Instead, aim for mechanisms that let everyone access the latest version of the dataset securely, even when you're sharing with external partners. It keeps things clean, consistent, and trustworthy. And here's one I love: democratize value creation through self-service. Imagine every business unit being able to access the data they need when they need it without waiting for a central team to do the work. That's what a true data-driven culture looks like. Data as a product comes in handy here too. It's like handing other teams a ready-made self-service toolkit so they can make smarter decisions faster. And the best part? It's empowering. Everyone feels like they can contribute to insights and innovation. Of course, you can't talk about data without talking about governance. Adopt an organization-wide data and AI governance strategy. That means controlling who sees what, keeping audit logs, tracking data lineage, and ensuring high-quality data throughout. You need a solid data catalog, quality checks, access control, and all that jazz. Think of it as the safety net that keeps everything reliable and secure. Then, we have open interfaces and open formats. This one's huge. Why open standards prevent vendor lock-in, make integration easier, and let you use the data across many platforms without extra cost or headaches. And finally, last but not least, build to scale and optimize for performance and cost. Data grows fast, workloads spike, and analytics demands can get heavy. So your lakehouse should be able to scale horizontally and vertically, and you only pay for what you actually use. Smart, right? A lakehouse is powerful, but only if it's built with principles in mind. Curate your data, eliminate silos, empower your users, govern responsibly, embrace open standards, and scale smartly. Get these right, and your data doesn't just sit there. It actually drives value, innovation, and trust across your entire organization. So now we will look into Azure Databricks Lakehouse reference architecture. First, let's answer the obvious question. What even is a lakehouse? Think of it as the best of two worlds. On one side, you have data lakes, cheap storage, flexible formats, massive scale. On the other side, you have data warehouses, fast queries, BI-friendly, structured and governed. For years, companies had to choose one or painfully glue them together. The Lakehouse changes that. It gives you one unified platform where data engineering, analytics, BI, and machine learning can all work off the same data. That's the big idea. Now let's walk through how this actually looks in Azure with Databricks. Imagine the architecture as a left-to-right flow, like water flowing through a system. We start with sources. This is where all data is born. Databases, applications, sensors, logs, streams. In Azure, that could be SQL Server, Azure SQL Database, Synapse has IoT devices, or even event streams. And here's an important point. Not all data has to be copied into the lake. This is where Lakehouse Federation comes in. Instead of moving data, Databricks can query external SQL systems directly, while still applying governance through Unity Catalog. So the data stays where it is, but it behaves like it's part of the lakehouse. Pretty powerful, right? Next stop, ingestion. This is how data gets into the platform, either physically or logically. There are two big patterns here, batch and streaming. For batch ingestion, Azure Data Factory or Databricks Lakeflow Connect are commonly used. These tools pull data from enterprise systems on a schedule and land it into cloud storage. For streaming, we're talking about real-time events, IoT Hub, Event Hubs, Kafka. Databricks structured streaming handles these streams continuously, so data arrives almost instantly. The key thing to remember here is this. No matter how the data comes in, it's governed from day one by Unity Catalog. Security, access control, and lineage are not afterthoughts. They're built in. Now let's talk about storage. This is the heart of the lakehouse. All data lands in Azure Data Lake Storage Gen 2, and it's stored using open formats like Delta Lake or Apache Iceberg. Why does that matter? Because open formats mean flexibility. You're not locked into one engine, and you get features like ACID transactions, time travel, and schema enforcement. On top of that, data is usually organized using the Medallion Architecture. Bronze, silver, gold, raw data, clean data, business-ready data, simple idea, massive impact on maintainability. Now we move into transform and query. This is where Databricks really shines. Under the hood, it uses Apache Spark and Photon. Spark gives you scalability. Photon gives you speed. You can write SQL, Python, Scala, and you can build pipelines using Lakeflow declarative pipelines, which make ETL easier to manage and test. Instead of writing complex orchestration logic, you describe what you want. Databricks handles how to run it efficiently. This layer supports everything: ETL jobs, ad hoc analysis, feature engineering, all from the same data. Next up, serving. This is how data and models are exposed to the outside world. For analytics and BI, Databricks SQL provides serverless SQL warehouses. Tools like Power BI can connect directly and query data at scale. For machine learning, you have Mosaic AI model serving. This lets you deploy models for real-time inference without managing infrastructure. And if you need transactional workloads, Databricks offers Lakebase, a Postgres-compatible OLTP database integrated with the Lakehouse. So analytics, AI, and applications can all coexist. Now, let's talk about analysis. This is where business users live. Analysts using Power BI, data scientists running experiments, applications calling model endpoints. The key idea here is that everyone is working from the same governed data foundation. No copies, no mismatched numbers, no my dashboard says something different than yours. Across all of this, there are common capabilities holding everything together. Unity Catalog for governance, data quality monitoring for trust, system tables for observability, Lakeflow jobs for orchestration. And on top of that, Databricks adds a data intelligence layer with AI-assisted features. So the platform doesn't just store data, it helps you understand it. So what's the big takeaway here? The Azure Databricks Lakehouse isn't just another data architecture, it's a unification strategy. One platform, one copy of data, multiple workloads, ETL, BI, machine learning, generative AI, all governed, all scalable, all working together. If you're designing modern data platforms today, this architecture is becoming the blueprint. Not because it's trendy, but because it simplifies what used to be incredibly complex. And that's really the goal. Make data easier to use, easier to trust, and easier to turn into value. All right, that's it for this video. If this helped you understand the Lakehouse a bit better, hit like, subscribe, and share it with someone who's still wrestling with legacy data architectures. And as always, thanks for watching.